we've been to the shop, we know where to get them from, we know how to tell if our ingredients are any good. And so now we are going to start with our first recipe, our first cake, which is for population growth. Now, before we start, one of the, I think, challenges, or the best things, depending on your approach, of teaching Common Core is we have a very wide range of capability when it comes to maths, statistics, and computing. Now, some of you are going to be incredible at maths and incredible at computer programming and statistical software. So many of you will be better than I am. Well, others of you are going to find this, are frightened of numbers, right? Some of you find this very challenging. Now, my goal is to bring everybody with us and not leave anybody behind. So for some of you, you might look at what I'm doing in this course and say, this is very, very easy. This is very boring. Well, I'm afraid that's just the way it's going to be, right? If you find it very easy, I can deal with people who say that it's too easy. If that's the case, then either drop the course, we've still got time, or just sit back, relax, and say, well, this has been pretty straightforward. I can't, however, handle people who are saying, no, it's too complicated, because then you just don't get anything out of the course. So let me be patient with me, for those of you who are amazing at maths, as we go through this in what is quite a slow and straightforward way. Okay, we're going to cover two measures in this video now. So you will need to get your calculators out, in fact, your scientific calculators out, or you can just do it on your phone. Okay, so first we're going to look at a very simple measure of growth over time between 2 points of time. Okay, it's basically just a percentage increase. Now, whenever we look at these letters and numbers, we might get in a bit of a panic. What does this mean? Whatever. Well, it's always easier to actually put some numbers to it. Okay, so let's take this here. So we are looking at the percentage difference between PT and PT plus N. So this is a fancy way of saying population at time T, which is always the first one here, which is going to be 9.3, and then population at time PT plus N. So here N is 10 years, because it's 10 years between 2021 and 2011. Normally censuses in some countries and some territories are in countries within 11, so that might be the reason for choosing these 2 years. Okay, so we are going to be looking at the total percentage difference between these two periods there. Okay, all right, so let's do this. So what do we have? We can then say, okay, PT plus N. So this is our second time point, and PT is our first time point. Yeah. So PT plus N is going to be 12.4. So we're going to put 12.4 there. PT is our first time point. This is going to be 9.3. We put that there. Okay. So in brackets, the first thing we've got to do is 12.4 minus 9.3. Then we're going to divide it by 9.3 by PT, and then because we want it as a percentage change over time, we're going to multiply it by 100. And there we go, is our answer, which is 33.3. And then we can go back to our original numbers, have a quick check, and yeah, that seems kind of reasonable, right? It's definitely growing. About a third. Yeah, that looks about right. About a third of 9 is about 3, so that is going to be about a third. Okay, so what we're going to do now is I want you to pause the video and try and do this simple equation for country B. Okay, so hopefully you did that, and let's see what the answer is. So the answer is minus 9.2. Okay, so we're not going to go through it again, but clearly we can see how this country is declining. The population is declining. Okay, and there are countries in the world where the population is declining. So that's the first check we can see, which is, oh, sorry, I should have put a percentage there. There we go. That it is in negative. And we can see, well, this looks about 10%. Well, what's 10% at 7.6? It's about 0.76. So yeah, that looks to be about right there. Okay, that's our very first nice and easy measure of growth over time. Now, what if we're interested in the annual rate of population growth? Okay, so we've got our 2 time periods there, but what if we want to see the growth every year? Now, we can't just take the total growth between over 10 years and divide it by 10, because it's not going to give us the right number, right? Because percentage growth is not going to be equally divided over the period. Now, we could just look at this and freak out and go, oh my God, what does all these things mean? Or we could just go through it step by step. So this is what we're going to do. Maybe you get your calculator out. You can do it all in one go, or you can just write down each step. Okay, we're going to do it one step at a time. So the first thing we're going to do is log 12.4 divided by 9.3. Okay, so this is a log, and then we're going to take the second time period here, 12.4, divide that by the first time period, 9.3, and then we get 1.25. Okay, then next we've got to do the bit at the bottom here, so that's N. So N is the number of years between population observations. Okay, so if we're taking 2011, 2020, 21, maybe 2 census years, that's 10 years. Okay, so here our N is 10. Okay, now we have to then do a log multiplied by the natural logarithm, okay, which is about 2.718. Okay. If you don't know what that means, I'm not going to teach log. You just maybe look it up or go and ask one of your friends. Okay. So that's nice and easy. So that's 10. So 10 years multiplied by log 2.718, and that gets us 4.342. Okay. And then the rest of it is easy. We just divide our step 1 by step 2 to get this number here, and then we're going to multiply that by 100, and then we get 2.9, which is our annual rate of population growth. Okay. And well, that's hidden away there, but you remember before, the population, we already calculated it, is growing 33% or so. Over 10 years, roughly 3% makes about sense. Okay, so now what we're going to do again, oh, excuse me, all of my things are still there. What we're going to do now is I'm going to pause again, and we are going to go through each step. I want you to go through each step on your own and see if you can calculate the same number for country B. Okay, so hopefully you've done that, and let's see if you got the same. Okay, so for country B, after I've rounded it here just for our purposes, but you should get a an annual rate of population growth or negative growth of about -1%. Okay, about -1%. Now, when we look around the world at the moment, you might think that population growth is a universal phenomenon. People talk a lot about, oh, there's far too many people in the world, but actually population growth today is at its slowest rate for many, many years, right? For almost a century. Okay, so the annual population growth rate of the world is less than 1%, and actually it was never really that high. If you go back to the 1960s or 1970s, it was over 2%. But of course, 2% of 6-7 billion is a lot of people being added to the world every year. Now, as you can see, in the future, population growth is forecast to decline, and there is, and eventually we will see global population decline. Okay, so here, although there is a decline in population growth, it is still above 0. So the world population is still growing here. But at some point in the future, and the truth is we don't really know when, different organizations say different things, at some point in the future, the global population is going to decline. However, global population growth is very uneven, as you can see here. So in some parts of the world, particularly in sub-Saharan Africa, and this is a pattern that we'll see quite a lot, the population is growing very rapidly. In other parts of the world, particularly in Central in Eastern Europe, including Russia, in parts of East Asia as well, the population is also actually declining. Okay, and then in many parts of the world, in North America, in Western Europe, population is in Australasia, population is still growing, but at a very relatively low level. Now, you might say, oh, what's going on here? Well, this is Venezuela. Population is declining in Venezuela. That's because a lot of people are leaving Venezuela for political and economic reasons. Okay, but that's not the primary reason which is shaping these over time, and what we see is a multi-track world. So this is something which we call, this is a very simple model of what we call demographic transition. Okay, so what is driving population growth? Okay, so here, this line here, total population, is a kind of stylized picture of population growth. Okay, now in stage 1, so this is basically in the past, you would have very high birth rates and very high death rates. Okay, we can kind of picture that. So that means that actually population growth is stable or slow. Okay, then what tends to happen is the death rate, which we'll talk more about later on, declines, but people are still having a lot of children. So under those circumstances, as you can imagine, population growth increases. Then mortality improvements slow down, but the birth rate then starts to decline. So that's when the growth rate of the population slows down somewhat. And then you get where we are kind of now, which is we have relatively low we have relatively low death rates and relatively low birth rate. So that's when we have only a slow pace of population growth. Now, what we're seeing already in some parts of the world, and it may well be that this is the case in other parts of the world in the future, is very, very low birth rates and low death rates. And that's when you start to see population decline. Okay. So what have we covered here? We've learned how to measure population growth over a period of time. We've learned how to measure annual rates of growth. We've looked at how growth is distributed around the world, and we've looked at what drives population growth, particularly through our demographic transition framework. Okay. Now, in the next video, we're going to look at how we can actually use Excel to speed this up a little bit, so we don't have to be getting our calculators out all the time.